Hi everyone, Sarah here with Signals Everywhere, and today I'll be showing you how to install the OP25 software. If you're not familiar with OP25, this lets you scan and receive P25 Phase 1 and Phase 2 radio systems. If you're interested in software-defined radio and radio communications in general, please hit subscribe and hit the bell icon so you don't miss any future content. Before we get started, the first thing we should always do is run a sudo apt update. And essentially all this does is it makes sure that all of our package repositories are up to date, so that way when we begin to install software, we're getting the latest version available for us. Now you can see I went to try and git clone the repository and it wasn't there. So we'll run a sudo apt install get, and that's get spelled G-I-T. That'll install the Git software so that we can pull OP25 down from the GitHub website. So we'll do a git clone github.com/boatbod/op25.get, and of course I will have a link to all of the software and commands in the description below. We're now going to change directories into the new OP25 folder, and we're going to run the installation script. Now this actually took a really long time to complete, so I went ahead and put a little overlay here. Just to give you an idea, it took at least a good 20 minutes or so, just going off of memory, to install the software, and that was on a halfway decent laptop, so make sure you set some time aside for your installation process. Now that our installation is complete, let's go ahead and run a sudo reboot to restart our Linux machine, and then from there we're going to hop in and start configuring the software for first use. The first thing you're going to want to do after you reboot is move into your apps directory. I'll go ahead and put the command on the screen for you. Once you are in that directory, we're then going to run the rx.py script with a couple of arguments, and these are going to start up our RTL SDR with an LNA gain set to 49. We're going to do a sample rate of about 2 megahertz. And you can just see as you're running through each of the variables, it's fairly straightforward. The -U is to play audio, -F to specify frequency, and you can see I put an E6 there. That's basically just adding 6 zeros. So that's going to move this into megahertz. And as you can see, we're getting a bunch of these weird tuning errors. Now, the reason for these tuning errors is that sometimes the ppm, or parts per million of your SDR, doesn't quite line up with the actual frequency you are trying to tune into. So you see at the end here we have this -Q. I had a 0 after it. We're going to change it to a -Q -1, and you can see we're still getting the same tuning errors. So as we change this, or rather I guess I had it as a 1, we're going to change it to a -1. And as you can see with a -1 on this particular SDR, we are now properly tuned, and you can see we now have the NAC, WACN, and system ID being decoded. We also have some voice calls coming in, along with the active talk group IDs and how long those particular talk groups have been seen. Having a terminal interface is really nice for a program like this, but in some cases you would be better off with a web-based interface. To do that, at the very end of our command we ran, we're just going to add a -L, http:// we're going to bind to an IP address, in this case just 0.0.0.0.0, which means any interface, another colon, and then 8080, which specifies our port number. With everything up and running, we can now go to the IP address and port number that we specified for our OP25 instance, and we will be presented with the new OP25 web-based interface. Now you can see it does see our frequency, 855.8625, but you'll notice there's no talk group information, no group or source address. It's really not generating any information of any kind. Now that being said, we can still pull up our plots without any trouble, such as our FFT, but we're not getting any kind of system data. And the reason for this is because we have not specified a trunk file. So let's go ahead and do that so we can get everything properly populated in our web interface. I have a trunk file in which I've already modified with our frequency information, so let me show you how to put this in. We're going to go ahead and get rid of the -F in our frequency. We're going to change it to a -T and specify the name of our file, in this case trunk.tsv, and run the application. With this application up and running with the new trunk TSV file, you can see now not only do we have our frequency information, we also have the name of the site or system, as well as all adjacent sites. And if we sit here long enough, you'll also begin to see other information such as voice frequencies come in over this web-based interface. This does give you the ability to do things like whitelist and blacklist, or go to a specific channel, so it is fairly flexible. However, you're going to notice the only thing you're really getting here as far as an identifier of who's speaking is a group address and a source address. Essentially, you're going to get a talk group ID. So what happens if you have the alpha tags, you have the text-based names of all these different talk groups you want to listen to, and you'd like to apply those to this application? There's a couple ways to do that. Let's go ahead and switch back to the terminal, and I'll show you how we can essentially link to another TSV file that has a list of all of our talk groups and the associated alpha tags or descriptive names. There's two things you're going to need to do this. The first is going to be a trunk TSV file that specifies the frequency of your site, and then on top of that we also need some type of TSV file with all of our talk group IDs. So let's go ahead and just edit a new one of those right here. And you can see I have the talk group ID on the left, a tab, and then on the right is the talk group alpha tag. So that would be our talk group list. Now let's go into our trunk TSV file. Now this trunk TSV is actually one that comes auto-generated with the application itself. We just need to make a couple little changes. You can see I've already changed the control channel frequency to my own, and you can see here we are now adding the talk groups TSV file that was just created. Now with all of that loaded here, we just restart the application. We're looking at the same trunk TSV file, but that trunk TSV is now pointing the application software back at our talk group TSV file, which is giving it a list of all of the text or alphanumeric names that are associated with a given talk group. So now, not only do we have a full web-based user interface for OP25, but we're also able to see the physical alphabetical names of the talk group itself rather than just a specific talk group ID, making things much easier to identify. Now, one of the biggest things with OP25 that I feel like has kept a lot of people away from it is the fact that you have to create your own trunk TSV. You have to create your own talk group TSV file. And I thought, wouldn't it be nice if you could just import all of this information from Radio Reference? So that's essentially what we can do now. I created my own Radio Reference import Python file here. It's a pretty basic script, but what it's going to do is grab the site and system information for your area and import all of that information, as well as create the individual TSV files for you, so that way you can get up and running a little bit quicker. Now, keeping in mind this is Radio Reference, so you do need a premium account in order to download this information. This isn't my stipulation, it's just how Radio Reference works, but it is certainly a lot nicer than copying and pasting from their website. So with this command, you'll be able to see that I have two files that were created automatically, both talk group and trunk TSV files. You'll see that these are separated by the ID of the system, 348, then the ID of the site, 19333. So if we go ahead and print out the contents of the talk group TSV, we'll see a list of all of the talk groups that are available on that particular trunk site. If we then go to the trunk TSV, we will see that a trunk TSV file has been created not only with our control channel, but our alternate control channels as well, and it's also linking to our talk group TSV. So once we run the application, we will be ready to go with both the talk group IDs, alpha tags being attached to all of those, as well as the trunk file already being created for us, so we can jump directly into using the software instead of sitting around having to wait while we create these files from scratch. Now, if the web-based interface isn't good enough for you and you're feeling a little bit adventurous, I do have another option for you. This is the P25 project's OP25 mobile control head. What we're doing is we're going to put the OP25 server address in our URL box here, and my application goes in, and pulls out all the data that's provided, traditionally through JavaScript. In this case, we're doing it through Python, all of the variables that are in the web user interface, and then applies it to my own mobile control head, which will eventually be mounted in my car. Now, at the moment, this is very, very far from being completed. However, it does have some interesting features, and I wanted to show you a little bit of how far I've come. It is open source, and this particular revision is available on GitHub, and I'm going to, of course, continue to update it. You see we have our hold function, goto, things of that nature. When we open up goto, we actually have the option to enter a specific talk group ID, which certainly comes in handy. If you release the hold button, that's going to, of course, release a hold whether you did it manually or if it was done using the goto button. We also have a call log to list the latest calls coming into the system. And I also wanted to show you one of the features I'm adding called night mode. So if you're familiar with GPSs, especially Garmin's GPS, right around sunset or dusk, you'll notice that you get a pop-up saying that it's nighttime and we're going to switch to night mode, which loads up a darker color scheme. So I'm going to go ahead and enable this particular threading function. Typically, this is going to use a GPS time sync in order to tell it when it needs to switch. But for testing purposes, it's going to wait for 15 seconds, and then it's going to switch the application over to our night mode and present us with that nice dialog, as well as switch out our color scheme. So there's a lot more going into this. The compass, for example, is going to turn for the bearing of the site that you're listening to. There's going to be an alert window, system details frame, and so much more. So a lot going into this project, and I can't wait to show you what's happening next. And of course, a huge, huge shout out to all of my patrons over at Patreon. I wouldn't be able to do this stuff without you, so it means a lot to have you there and have you working with me, hand in hand to build some cool software and make some really cool videos. I wouldn't be doing this stuff without you guys. And I really appreciate all of you being here. So thanks again, and I will see you all in the next one.